All right, so today we want to talk about what happens when we have a limit at infinity, which is different from infinite limits. So what we're talking about here today is how to determine what happens when x becomes increasingly large. That means what happens as x approaches infinity, or as x becomes increasingly large in magnitude but negative, or as x approaches negative infinity. And we're going to talk about the function that I have up here. So for example, we're going to talk about the function to start off with f of x is equal to 1 over x, because this is going to be what we're going to base a lot of our judgments on. Now, if we graph this function, so this is the graph over 1 over x, but what's important to realize is that limits to infinity, they occur at horizontal asymptotes. And if we look at this graph, we have a horizontal asymptote here. At x is equal to 0. Now, if we take a look at the limit as x approaches positive infinity, so over here on this side of 1 over x, we can tell it from the graph, but also if you look at this numerically, whenever you have 1 divided by a very large number, that becomes increasingly small the larger that number is. So if you have 1 over 10, that's 1/10. 1 over 100, 1 over 1,000. So every time you increase that by power of 10, you're moving the decimal place over. So as that x gets extremely large, that number is going to get closer and closer to 0. So the limit as x approaches infinity of 1 over x is equal to 0. And we're going to use this as the basis for what's coming next. Now, as you can see, if we look over at the other side of this, if I have the limit as x approaches from the negative infinity side, I have a negative. This is still getting very, very large in the bottom. And this time it still approaches 0. So those are both the same. It does not matter whether it's positive or negative there. Let's go ahead and look at another one. And for now, I'm going to go ahead and draw these graphs, but we don't need to have these graphs to see what has happening at the limit. All right, this is going to have an asymptote at 2. And I'm going to go ahead and talk about how the general rules for those asymptotes in a minute. So this has an asymptote of 2, and the graph itself looks like this. Now, if we go back to our limit laws, I can go ahead and take this and break this up. What this is the limit as x approaches infinity of 2 plus the limit as x approaches infinity of 10 over x squared. Now, the limit of any constant, that just becomes 2. Now, the same thing happens here. Whenever you have a constant over a variable, and that's all we have, that limit is still going to be 10 over a very, very large number. So all of this is going to equal plus 0. So the limit here is equal to 2. Now, let's go back and review horizontal asymptotes for just a moment. So review for horizontal asymptotes. If you ever have a function f of x, where this is a x to the n over b x to the m, whenever n is greater than m, there is no horizontal asymptote. If n is equal to m, y is equal to a over b. And again, this is our horizontal asymptote. And if n is less than m, it's y is equal to 0. Now, just a word about this, even though this says that there are no horizontal asymptote, what happens here are slant or oblique asymptotes. So to look at a couple of examples here is if I have f of x is equal to x squared over 3x squared plus 5. Because both of the powers are the same, the horizontal asymptote is going to be a ratio of what's in front of here, or my y is at 1/3. Now, this is not to be confused with something that looks like this, 1 over x squared plus 3. So just a little warning here. This does not follow this rule. And the reason it does not follow this rule is it has this plus 3 added to it. For this to follow the rule, you'd have to find a common denominator, which is 1 over x squared plus 3 x squared over x squared, or 3x squared plus 1 over x squared, which gives you the horizontal asymptote of y is equal to 3, the coefficient of the x squareds. Now, I can tell that in the beginning because this plus 3 is a vertical shift up. So do be careful when following that rule.